It's Thursday morning, so why not wake everybody up with Chuck Berry? So, what we're going to be doing here is decomposing music with the Microsoft stack and some Python. Basically, we're going to be looking at the DMUX library, which is a convolution neural net in Python, and then an FFT, a spectral analyzer. Combine all of this with the front end of Microsoft, and then IoT Central, and so on and so forth. That's the whole talk about. And if I were to move this forward, actually, I should probably just stop here and run right over. And I'm sharing the sound here. So, and I'll make this louder. And let me see, kindly let me know if you can hear this. So that's that. And frankly, it's not exactly a laughing matter because one of the things that got me started on this was for my kid. I've got two monsters. One is 12, and for him, I thought I'd get him started on classical music and Eastern Indian classical music, actually. And for that, there are two things that happen. One is developing a sense of rhythm with what's called as the tabla. Some of my Indian friends might actually know. And the second one is to get a hold on pitch, if you will, right? So if you want to know the rhythm, isolating just the beats is very important for the kid to kind of know the rhythm and sing along with it. So that got me started on this. The second thing was if his teacher is actually at a certain pitch and he's at a certain pitch, I want to be able to take the teacher's voice and then frequency shift it to his so that it's at his level so that he'll be able to learn. That's the whole reason why I got started with this. And, this brought back my engineering roaring back. I mean, my grad school was back in the mid 90s. And it was actually in wave motion and so on and so forth. So I slapped in the FFT over here, the fast Fourier, to kind of split out the frequencies and so on and so forth, right? So that's the whole rub. The front end of this is Power Apps, as you can see. And essentially what it's basically doing is, if I were to go over to the formulas over here, it basically connects to Azure, blob, and then pulls in all the files basically. So this is my Azure blob, and here are all the files. There are multiple ways of actually managing this, as you folks know, very well know. But for me, that's an easy way of actually interacting with the files, especially music files and such. So I've got a whole bunch of files here that interact. So that's the starting point. Then when I send this actually over, so let us say I've got my audio. When I send this over, I use Power Automate to do bidirectional comms. So this is telemetry, basically telling me that the IoT hub is connected and so on and so forth. Or when the music has been parsed by the DMUX library, I get a notification, so on and so forth, into the app. But I use Azure IoT Central because I could use IoT Hub and then use the custom connector in Power Apps, but I didn't bother with that. Just use the available Power Automate, which was simple enough to actually do. And then, of course, you've got IoT Central. I mean, I could easily use IoT Hub as well, but who wants to mess around with JSON there? Here it's dead simple. Just go and set up a bunch of in the device template, set up a bunch of commands and telemetry, and then you just use Power Automate to get to Python code. So that's this component of it. And then, of course, you've got your Python code. Essentially, what happens here is, you have IoT Central, which basically receives the commands here. So I'm not going to go over that. That's fairly well known. But the thing that actually got me interested was the DMUX library. This one here that actually separates out, if you will, the different streams. And I'm talking about drums, bass, and so on, vocals, isolating them. So that's one component of this. Now, does it work well? Obviously, as you see with Western music, no problem. This is absolutely fantastic. But if you go to Indian classical music as an example, not so great, right? So it needs a fair bit of training. So you have to sort of get into the model a little bit and customize the model, which is a lot of fun. So that's one component of it. The second thing is you could actually use, you saw the spectrogram. So essentially you could basically use FFTs over here, fast Fourier transforms in Python. That works wonderfully as well. The only issue is if you have the voice at, let us say, 440 hertz or whatever, and then the beats at 440 hertz, if you just use the FFT, even though it isolates the frequency, you won't be actually able to know whether it's voice or it's actually the beats, right? So you won't know. So you would have to do the FFT first, then pass it to demux for it to separate out because this is based on CNN, as that component with enough training seems to work reasonably well. So then you do a combination of these two to improve the accuracy of the whole model, right? So a few caveats over here. This is clearly, I mean, I've got my, PC, absolutely fantastic PC. It's got the Ryzen, the CPU. It's also got a GPU inside. So I'm able to run this here. I also do a bunch of CAD work. So I've got like 64 GB of like RAM here. So that helps us a little bit as well. Now, I don't know if I'd be able to simulate or actually get the spectrogram on Azure. So I have to kind of do it here on my PC or locally, and then come in from Azure onto this one. So that's kind of a little bit of a hiccup, if you will. But if you just want to separate out and then bring those, the voice, etc., back and assemble it inside your Power Apps, you could do that in Azure. Okay, so that's about it.